Okay, hi everyone, I'm Philip. Let's talk about services and how to monitor services. So I work for Elastic, the company behind Elasticsearch, Logstash, Kibana, Beats, like what used to be called the Elk stack. Now we try to call it the Elastic stack since we have this new open source component called Beats and there is no B in Elk, so had to kind of rename. I'm part of our infrastructure team. So we do stuff like AWS, containers, automation with Ansible, Chef, Puppet, Terraform, Jenkins, various things. And then I always say, like, this is a Unix pipe. I kind of pipe that into developer advocacy. So I talk about a lot of the good stuff that we kind of do. So the starting point of this talk was basically that quote I saw on the internet, which I found very nice. So if you have this like highly distributed architecture, outages are getting much more interesting because suddenly it's not that simple as looking into one log file anymore and maybe SSHing into a server and then doing a bit of tailing and using Wireshark because like everything is distributed, everything is somewhere, and it's much harder to grasp what is even going on. Or to put it, like Sam Newman, he's very big into the microservice world. His two main points are what you need to do to be kind of successful afterwards is you have to need these aggregated logs, and then you have some correlation IDs so that you can actually follow what is going on in your system. And we'll try to do both of these two things, and we'll try to add some more stuff around that. So what we kind of want to do is we want to monitor and log all the things and put it ideally all in one system and see what is going on. So how is everybody logging already? Who's using SSH and tail or less or something like that? Okay. Well, that is the ideal talk for you then, I guess. Who's using more than 5 servers? Okay, that's also quite a few. Is it fun to use tail and SSH on more than 5 servers? Maybe, maybe not. Let's see. Maybe there are better alternatives. So let's see. All the code I'm showing you is available on GitHub. And the nice thing is it's all in the cloud, and you will actually generate the requests for my service later on. So everybody who has their laptop or phone out, you will need to use that during the talk. So let's take a look at an application. I'm using Spring Boot, but it doesn't really matter. The code is online, but it's very simplistic. I'm not doing anything fancy because it would just distract from the thing I'm doing. So there's no discovery, load balancing, security, anything. I'm pretty much following the approach. I call it microservices because my API names are short. That's one of the approaches. Like I'm leaving out all the other fanciness. So let's just say we're monitoring something that talks HTTP and monitor those services. So yeah, we take some Spring Boot code, we add some dependencies. I guess most have seen that in some other talks yesterday already, how to work around Spring Boot. So let's skip that part. Basically what I do is I package some code, I deploy it, I run it as a jar file on my service. That is all very standard. And of course it's running in the cloud because everything needs to be in the cloud. I'm using AWS Lightsail. Anybody heard of that? It's kind of the cheap service AWS is offering. Is a bit like DigitalOcean. It's $5 per month for 512 megs of memory. I'm using Terraform to provision those, and then Ansible to configure my service and roll everything out. So that is kind of the services that are running. Let's assume that is all up and running, and we'll just use those. And I will log all of the information to, since we have at Elastic, we have our own cloud service providing Elasticsearch and Kibana. I'm using that. So that is kind of where we are redirecting all the traffic and where we'll do the visualizations later on. If you want to do that locally, of course you can do that. We have Docker images, everybody needs Docker. What you normally have in your stack is something like that. We will have the beats, which are like lightweight shippers or forwarders. They're written in Go, so you get native binaries and no dependencies. And in our example, we'll keep it very simple. We'll just stick to these 3 components. We'll leave out Logstash for the heavier parsing. We'll just have beats forwarding to Elasticsearch, and then in Kibana, we can actually visualize what is going on. So what do we want to... Don't hurt yourself. Let's see what we can monitor. So the first thing what I want to do is, I have something, I called it a bad jar. It's basically just allocating memory until it's running to an out of memory exception. Some people might say that's kind of the default behavior of Java. Let's not discuss that. So I give it a bit more resources. So before we start that, let's open up Kibana. Who knows Kibana? There's quite a few. Kibana is kind of the visualization tool we have sitting on top of Elasticsearch, and it's kind of the window into your data. And I'm pretty lazy. Like, I used everything we have pre-built, and one of the pre-built things we have are these dashboards around various things. We have something called metric beat, which basically collects system metrics. And I'm now interested in basically what top would give me. So I have two servers running here that are being monitored. You can see they have some processes running, and you have the CPU usage and the memory usage. Like, I'll make that a little smaller. Like, you can see this is one server, this is the other server on the CPU usage, and this is their memory usage. So both of them are running here. We don't really know what's going on, so I'll just start my bad jar, and pretty soon it should be obvious what is going on. And I will actually switch on auto-refreshing, so that page will auto-refresh every 5 seconds, so that we hopefully can then see what is going on. So now that I run my bad jar, it's not doing anything. It's basically just sitting there and allocating memory. And now that we switch over to the metric beat, it will refresh every 5 seconds, so it will now take like 2 or 3 iterations until you finally see something. So on one of these servers, I started my bad jar. I assume you can already guess which one it is. And if you look into the process, you see here, we have Java here. So Java is starting to take up a lot of resources. And it will take more and more and more until it crashes after like 5 iterations or so. Once it has allocated all the memory it had available. And then it will fall down again. And if you were just using top, you probably easily miss that, because that process is just running for half a minute or 45 seconds, something like that, before it crashes. So you might miss out on that. But having that view, you actually see what has been going on in your system. Did it crash already? Let's see. Yeah, okay. It did what it was supposed to do. So it just generated its out-of-memory exception, and you can see, okay, we had this big spike here where the Java process was taking up, I don't know, how much memory was that? Somewhere, if I find the right tip. No. It's too tippy. I'm switching between processes, but you can see it's taking up like 50% or so of my memory, and then it crashed, and now everything is normal again. So we had this spike here, and now that is gone again. But let's do something a bit more productive. Let's start the proper something that is just talking back to you. Let's start that. So I have 2 things I need to start here. I have the monitoring part in Zipkin. We will get to that later on. I'll just start that so my application can connect to that. And I'll also start my application. So that is the default Spring Boot application. It's kind of exposing 2 or 3 endpoints you can hit. I guess most of you are familiar with that. It will start up like in 15 seconds or so. Nothing fancy or spectacular here. Yes, started in nearly 15 seconds. So that is good. And then you can actually reach that one at, if you go to sierra.wtf/good, it will actually show you, okay, it's not giving you anything else. You can go to foo or something. It will show you, okay, that is not found. We can go to bad. That will just trigger some exception, and that has all happened in the background. And now we maybe want to see what is going on here. We don't really want to instrument our application. We just want to see that mainly maybe from the network layer. So we have something called packet beat that is just watching on the network interface, and it's extracting the information from the headers which you can get. So the first thing we can do is we have something called flows. There you can just see like how much traffic is being generated on that instance in general. So you can see how many connections do we have, which hosts are talking to that system. That might be for a real world application, might be much more. Like who is sending and receiving traffic and which are the top IP addresses where stuff is going on. This is very generic. Like if you do not understand your protocol or your protocol is encrypted, that is all we can extract. But if we do understand your protocol, we can see much more. For example, if we have something called HTTP, like HTTP, you can see those were my requests here, and you can see we hit we had like 4 people hitting bad, good. Yeah, we had fav icon / and the foo I hit was hit once. Since this is auto-refreshing, feel free to generate some requests. Like anybody who has out their mobile phone, it's pretty much it's xera.wtf / good, bad, or whatever you want. And you will just get some messages. Getting more requests is nice because we will later on see your location and your user agent, so the browser you're using. So if you generate some requests for me, we will have some data for that, and it's less boring than if I just hit it from my one Chrome instance. So all of that information is being captured. I'll switch back to here so you can see. Yes, thank you very much. We can see we're getting more and more requests. We have more good, we have more bad. And you can see which were the top URLs done. And yes, somebody hit cool. That is very nice. Hello there. Yes, I had lots of messages in the past. Like, yeah, normally the German audiences are very serious. They just go to good, bad, and foobar or something. More active audiences are going to different URLs. I had people try to do JavaScript injections as well, where they put in script alert hello or something like that. That doesn't work. You can try it out. It's fine, but yeah, that doesn't work. But you can see, okay, we have captured all these requests here. And somebody says ugly. Why ugly? Yeah, the good, the bad, yeah, good, bad, yeah, that is, okay, that is a good one, yeah. So we have extracted all of that information basically just from the network headers. So we know, okay, this is the protocol, the response code, which was the URL, and we can also see stuff like how long did it take. But we can also do other things. So what I have done is my Spring Boot application is running on port 8080, like maybe it should be, because otherwise you would need to run it as sudo to bind it to port 80, and yeah, don't do that. I'm having Nginx as a reverse proxy in front of it. And we have something called FileBeat. FileBeat is there to collect your log files. We'll get back to that to see what caused the 500 error message later on. But FileBeat can do something else now as well. It's pretty new. It's called FileBeat modules. And it basically knows for some well-known applications like Apache or Nginx or MySQL, it knows for your operating system, the log files are located in this place. So we can actually check that out. Do I have? No, I need to add another SSH connection. If anybody is bored, you can try to connect by SSH as well. We'll look into that in a second. Depending on how playful the audience is, some people are trying to break into stuff immediately. So what you normally have is in the access log, like you get these log lines basically, which are, yeah, okay, you have an IP address, you have a date, you have the HTTP verb, you have the URL, you have the response code, like you have the user agent, you have all of these bits and pieces of information. And previously you could write your own patterns to actually extract that information, but at some point we figured out like this is very common and nearly everybody wants to do that and nobody wants to add these patterns. So now we have built that into FileBeat, and FileBeat is actually doing the parsing for you. And again, we have a nice dashboard for you to show you what is going on. Since I'm lazy, I didn't have to build anything myself. So if I switch over to Nginx, this is what you will get. You can see most of the requests are, well, little surprise from Latvia or from, but either some people are using VPNs or your IP addresses are in the kind of the wrong area. But yeah, you can then start drilling down, and depending on how good the geo information is, it doesn't seem to be like whatever the free Wi-Fi that everybody is using here is, like, that doesn't seem to be, like, it doesn't assume that it's here. But yeah, GeoIP lookups are always interesting. Like, sometimes they're pretty good, sometimes they're not that good. It always depends. Then we have extracted here the, like, how many requests, and you see what were the response codes. So yeah, we have 200s, 500s, 404s, and 499. There were no errors within Nginx itself, but you can see, okay, these were my top URLs. So good had 70, 200 requests, and 6, 499. Down here we have actually extracted the browsers, so you can see, okay, this seems to be Chrome Mobile, this is Safari, Firefox Mobile, and that was jumping around this other. No iPhones? But there's, oh, sorry, mobile Safari, that's mobile Safari. So, okay, yeah. So it looks like Chrome Mobile is definitely winning. And based on the operating system, we can see, okay, Android is 40%, and iOS has, if you stop jumping around, 26%. So you can see how much traffic, what operating systems, what browsers, and that information is all just extracted from the access log. So we didn't have to instrument or parse or anything or do anything complicated. This is just extracted from the access log. We support that for Nginx and Apache. MySQL is also supported by now, and stuff like systemd. Or we can check out SSH. We're parsing the SSH logs as well. Did anybody try to? Yes. Somebody tried to log in via SSH. Maybe you or some random bot that tried to scan the internet. So that, yeah, that is kind of a common pattern, that you will have some successful logins from yourself, and then various people trying to log into your server. And you can see, yeah, where are they from? What users were they using? So somebody used guest, somebody was using anonymous, and here you would see IP addresses from where they are, etc. We have something called audit D, so you really see what is going on in your system. Okay, I didn't do any sudo commands lately, but if you do sudo commands, you would have them in the audit log as well, so you see what is really going on in the system. Okay, so we have monitored the logs and the system part. We have the system metrics. We looked into the network traffic. So yeah, you could use Wireshark for that. It's using the same base library as PacketBeat as well, libpcap. But like using Wireshark in a distributed environment is kind of a pain always, so PacketBeat is always so nice there. The next thing we might be interested in is what caused our error, because if you hit bad, you got this 500 error message, but we don't really know why. So let's see what is going on there. So what I've done, normally you would log out as normal log lines like we have seen in the Nginx access log, and then you will need to parse them. But that is always a bit painful, that parsing part. So what is easier is if you can log out as JSON directly. So I have logged out log apps and front end JSON. So my application already logs out to JSON. This is basically a special, I'm using logback as you have a JSON logback appender basically. So you can see we have stuff like, we have a timestamp, we have a severity, we have the service name, we have traces and spans, which we don't have right now. And then you have, here you can see this is already a stack trace. And since we have that structured, we can just take that JSON, store it in Elasticsearch, since that is storing JSON as well. And we don't have to do anything special anymore here. So if I go to my Discover view, here we see all the different kinds of information that we are capturing. Like some we have already seen, some we will see in a bit. I'm sticking to FileBeat. Let's make that a little bigger. Then you can scroll down and see, okay, what types of information do I have? So I have log. This is basically what the system logs, like the Nginx access log, the SSH logs, etc. And we have some logs from our Java application. And I'm only interested in my Java application. So I will filter down to those. Now we have only 113 hits to our Java application that we have logged, and we see various messages here. So what might we be interested in? For example, something that could be of interest is the JSON severity and just errors. So let's filter down on that. I'm going for JSON severity error. And then you can see, okay, we just had 36 error messages on the severity. And then you can see, okay, why did this actually happen? And you can see here we have a stack trace for that. And then you see, okay, blah, blah, blah. And the log message I had, my bad, something went wrong. So then you can start tracing down, like, where did my errors come from and what did happen here. And you can see it's annotated automatically with some other information. So for example, it knows the instance ID. Since this is running on AWS, we add that meta information automatically. I don't need to do that explicitly. It knows the region, it knows the instance size, so I'm using a micro instance, and it's basically running on EC2. So we have extracted all of that, and you can see like which host name, which application name, since we had front end somewhere here. So if you have lots of applications, you can then filter down by specific applications to see what is going on. So this is actually very nice to see how is your application doing. One other thing you might be interested in is like, is my application even alive, up and running anymore? So let's start that. We have a component called heartbeat, and that is basically pinging your services and checking if it is up and running. So to start that, I'll just start. And just to give you a quick idea what the configuration looks like. That would be the configuration. So I'm pinging /good every 10 seconds with the timer of 3 seconds. I'm expecting a 200 back. I'm adding the cloud meta information already. Yeah, don't steal my credentials to my cloud instance, but I'll reset that afterwards anyway. So this is where all my logs are being sent. Like, yeah, I will reset that afterwards. So now, for that, oops, no, I don't need IntelliJ now. For that, we have pre-built a dashboard again as well. Let's switch over to that dashboard. So that is called Heartbeat. And if everything is working correctly, we have started it like a minute ago. And you can see, okay, yeah, here I started my heartbeat. Everything is green right now, so it's working as expected. To check out, is it really working? Let's kill our application. Okay, application killed. Let's switch back to the heartbeat. It will take like 2 or 3 iterations until we actually see it's down. Let's wait for 1 or 2 refreshes, and hopefully, yes, you can see now it's down again. Actually, how did we get started with Heartbeat? Since we have our cloud service, we were using lots of external services in the beginning to ping our stuff. And at some point, the cloud team came along and said like, hey, we want to use our own stuff. And they started kind of writing this Heartbeat on their own. And then they handed it over to the Beats team, and now they're doing that properly. And you can see, okay, service is gone. Everything that we are pinging is red. I'll pause that for a second. And some other nice things is the Heartbeat is not only pinging your service to see, like, is it up or down, but it is also making sure, like, what are your response times. So it will extract, like, what is the overall response time, but it will also know, like, how long did it take to establish the HTTP connection, the TCP connection, and if you have it, I don't, in that example, SSL. So it will break that down, and you can see, like, what is taking how long, and that should also make it much easier to debug if some connections break or are not that stable. So you can see our connections took like 70 milliseconds on average, and you can see, okay, the HTTP request was very fast, and just the resolution of the request in the beginning took some time. And we have a heat map of how long the request took. So the first one took a little longer, the later ones were very quick, like they're less than 50 milliseconds just to reach that endpoint and ping it. So if you have need to guarantee some SLAs, that is a very nice way to see how long all of that is taking on average. Okay. So that is working. Something, I will start up my application again so we can use it later on. And we can stop the heartbeat again. One other thing that might be interesting is if your application is exposing some kind of metrics. So if you're using Spring Boot, you know there is health, which tells you like, yeah, the status of that thing is up, some disk space information, and the refresh status. And there's also metrics, which will tell you like how much memory is there, stuff about the garbage collection, your heap size, the requests, like how many requests did you have on 200s, 404s, 500s. So it will extract some information, and that is very nice here, but it's a bit ephemeral. So it would make sense to collect that as well into Elasticsearch, just so that we have it and see what is going on. And while we don't have that yet, somebody from the community was nice enough to write a beat called HDP beat, which will actually, in the next major version, we will take that over. But that HDP beat is basically going to some endpoint and fetching information from that. So I can show you. What I'm doing here is basically I'm pinging health and metrics. You can see every 10 seconds I'm expecting a JSON response, so I can actually parse it correctly back, so I don't need to parse that explicitly. You could do authentication. I have disabled it in my example. And then we're storing the result just in Elasticsearch directly again. So if I start that, yep, I want that one. And then we can switch over to the Discover view, and we don't need that filter because otherwise we will not find anything. We want to find everything here. And then we switch to that HDP beat, and then you can see, suddenly we started it up. It got the first two requests already, and we have that information that we had previously just in health. We have that nicely extracted in Elasticsearch already, and now we could just like build our own graphs based on, I don't know, let's open up one of the health endpoints. 200s and 404s did you have, or what is your current heap size, and then you could draw out the heap size over time. And it's jumping a bit right now because we have this auto refresh enabled, so every 10 seconds a new request will come in. But here you have extracted all of these metrics, and it's very generic, like we didn't have to configure anything specifically. As soon as your application is exposing some JSON endpoint, you can simply collect that, store it, and graph that out later on to see what is going on. The next thing you might be interested in, like if you're calling some services and you have lots of services and you need to know what is slow, if something is slow, is you want to have the tracing of those messages. So let's quickly jump over to that since we have seen the rest already. So in Spring Boot, there's something called Sleuth, which is basically detective. I think it's a very British term. And it's basically like tracing every request you have in your system. So for example, what we have here, this would be a request that hits two calls internally. So we have something that is logging calling home, and the other method is logging basically you called home. But what is more interesting is the stuff between the first square bracket. And to break that down, you can see what we have in there. The first thing is the application name. So I have given it an application name. So if you have lots of applications, you will see which application, like which jar file did you hit, or did that request actually hit. Then you have the trace ID. The trace ID is assigned when the request first hits your system. And that trace ID will be kept over all the internal calls. So that is how you can actually follow one request throughout the system. Then you have the span ID. The span is basically a unit of work, or think of it like one method call. So we know how long one method call took. And the final parameter basically says send that information out so we can collect and visualize that. So if we You can follow along if you want to. Otherwise, I'm just generating some requests. I'm hitting /call, and that is, you can already tell, like if I refresh, it's not really responding immediately. It is taking some time, so there is some delay. So what I have done is I have two method calls. One is calling the other, and there is a random wait in there. And I want to know, like, where is that random wait? And for that, there is Zipkin. Zipkin is basically a server that can store that information. Conveniently, it has multiple backends where you can keep that information. It could either be within our in-memory. It can store its data in MySQL, Cassandra, and luckily Elasticsearch as well. So you can store those trace informations in Elasticsearch there again. So since it's now, let's say 11:45 when we expected the first request and the last, so I'm interested in that 15-minute time span today, and I want to have the 10 slowest requests I hit. I want to see those. And if I hit find traces, you can see we had a few requests. Two spans basically means we had two calls, like two methods had to be called, and the whole thing took, like, the slowest we had was 1.7 seconds. And if I open that one up, you can see, okay, the /call, that took really a long time, whereas the calling then the /home, that was super quick. So home is quick, but where you need to debug, like, what is going on or what is bad is in /call. You can actually do the same with nested. Then it will call, like, more things internally, and it will get even slower. And the other thing is, I think it's called call bad, if I remember correctly. That has timeouts plus response in the 500 in the end. Just to see, like, what the 500 looks like, if I go back here and I find my traces which have happened since then. Oh no, my call bad was not slow enough. I hope you're getting slow enough. Yeah, you can see the red ones, those are actually errors. The green, the blue ones, those succeeded, but they were just slow. So for example, here you can see it took nearly 3 seconds, and we had 3 spans, and you can see, okay, this one took quite some time, then the call nested took some time, the call took even more time, but the home was then quick. So that is, like, you collect information. Normally, by default, Sleuth will just, or Zipkin will just collect 10% of your calls, which it assumes is kind of representative. You can collect more or less depending on how many requests you have, but you don't want to spend all your time in your application just collecting these requests. So you take a sample of your requests, and then you can just see, like, which ones are the slowest ones, or which ones have errors, and then you can start debugging and check out, like, what is going on here? Why is this slow, or where is this error happening? And thanks to this kind of waterfall representation, it should be very easy to see why is something slow, or what is actually going on in your system. So you can see the slowest requests took that much time, then we had some errors, and yeah, lots and lots of errors. So here you can really find, like, what is slow in your system and how you can find out why it's slow and where to start debugging. Okay. Yeah. One thing I always forget. If you're debugging something, it might be very convenient to actually see why is this going on. So you can register a Zipkin server. I'm afraid I cannot make that much larger down. Much larger down here. So I'll try to get it up a bit more. So what you can add a plugin to Chrome. For Firefox, it's also available, but it's experimental right now. But for Chrome, there is a plugin. So what you can do is you can copy the Zipkin server. You can kind of register that one. Let's add it. It has been added. And now, whenever I call that, and yeah, it has taken quite some time, you can see, okay, we did one request, and we have the trace ID here. So with that browser plugin, it's actually very nice that you can then jump in directly into Zipkin and see that specific request. So if you're debugging something and you find some page that is slow, if you have that plugin, you can jump directly to the Zipkin server to see what has been going on here. And yeah, so the bad call took over 2 seconds, and that one added 1.7 seconds more. So it was both a failure and bad, and here you saw what was going on. And you can actually open that one up. You see, okay, the response code, and what has been going on in the background. So that is all the stuff that Zipkin is collecting and that you can see later on. Okay, more other stuff you could do, which I'm not covering today. So if you're using our cloud service, there is something called alerting included there as well. So if you suddenly have more 500s than you expect, you could send yourself an email, PagerDuty, any webhook call, whatever, just to get alerted. So you're not just collecting the information, but you can be notified what is going on and going badly as well. And something that is very new, unfortunately, that is commercial. We have something called machine learning. That is kind of learning over time what is normal in your data. Be careful, machine learning is a very overloaded term. It's anomaly detection of time series data. Since we have time series data like we have our calls, it learns what is normal for that specific day of the week or that time of the day. So it knows like Friday at 12 o'clock. Normally we have that many requests or that many errors on our site. And if it's out of the ordinary, it will create an upper and a lower bound. And if it's out of those bounds, it can alert you. Okay. What else is there what we should add? So something that we will have very soon is annotations in Kibana, because right now I've just shown you the graphs and yet you see, okay, you had lots of 200s and suddenly you have more 500s. What would be very nice in those graphs is if I had like some annotation and the annotation would tell me, oh, you have deployed something, or maybe it even knows like person X has deployed something here. And then you see, oh, suddenly the 500s are going up. I will need to find that person and talk to him or her to see what that deploy did, because obviously something is going wrong here. So we will have those annotations in Kibana very soon. Another thing that I find very cumbersome for my demos, like everything else is automated with Terraform, and I can just create and destroy that application and set up within 3 minutes or so, or however long the Amazon API takes. But our cloud instance, I still need to create manually. The problem is we don't have a public API for our cloud service right now, but we will get that soon. And as soon as we have that, we'll add the Terraform integration, and then you can also automate that part. Something that is very commonly requested, which we will also get like maybe later this year, maybe next year, let's see, are rollups. So today I'm interested in 10-second intervals. That in 2 weeks, I might only be interested in like 1 minute or half hour or whatever intervals. Right now, there is no easy way to do it. Like you would need to write your own logic to kind of read out the data, aggregate it, and then put it back. But we will provide something that can automatically kind of, make your data a bit sparser and aggregate it together, just to store disk space and make calculations in the future, or like for stuff that has been far in the past. Quicker, because there's less or fewer data points you need to collect. So those will be available soon as well. And something that is very commonly asked for, like when do we get a Zipkin plugin for Kibana? I don't know. Like I still need to convince the developers, basically. I'm not sure how aware that they're of Zipkin and that we could add plugins. But since Kibana provides a plugin system and you can just add your own applications, it's possible in theory. You just need to do it. The just part is always the difficult one. But let's see. It would be very cool to have this Zipkin integration or something like APM monitoring in Kibana as well. But I'm sure we will have something in the future. So to conclude, what we have seen is we had a very simple application. We have it in the cloud. We collected the system metrics. So we know, okay, CPU, memory, how are those resources doing? What is the network doing? Since we had from packet beat the information like how many requests did we have, what were the endpoints. We collected the logs both from Nginx, where we got locations through GeoIP lookups, we got user agents, we also saw like what is going on just from Nginx itself. And then we looked into the application logs, and ideally you have something that is structured already like JSON, Otherwise, you will need to parse it to get all the relevant fields out, and that is normally a pain, especially if you have something like multi-line statements. For example, stack traces. Yes, you can do like patterns and say like every line needs to start with a square bracket, and if it doesn't, it's a multi-line statement, then group it together until you find the next square bracket. But it's always a bit cumbersome to parse that correctly. So ideally, you have something that is structured. We can monitor the uptime with heartbeat. We have the application metrics with HTTP beat, and HTTP beat will actually be part of metric beat in the next major release, which is 6, which will come out later this year. So then we can kind of bring home that functionality what some user provided so far. And you have request tracing that was pretty much integrated into your application, for example, in Spring Boot via Sleuth, which is basically generating these IDs, and then you can just send those to a Zipkin server, and the Zipkin server can then use Elasticsearch as a backend again and store its information there. Any questions? I have lots of stickers here. If you want stickers, grab stickers. And we're well in time, I guess. Any questions? Yes. Wait, microphone. Or if you're interested in any other stuff like Terraform, Ansible, the Java application, I can show you more stuff.
Hello, my question is, if I want to run this Kibana thing and Elasticsearch against my own server, what should I set up on server actually?
So what you will need to have, so on your server, so where your application is running, you have the beats. These are collecting the information, and they're sending that out to some endpoint. So either you can use a cloud offering, or what you will need to run is Elasticsearch plus Kibana. We have Docker containers for that. We have packages for Debian and Red Hat. We have like general tar GZs. So you will need the JVM for Elasticsearch, and then you can just run that. So that should generally be very simple. So you can just use apt-get install Elasticsearch and apt-get install Kibana, and that's bringing everything for you. Then you have the endpoint, and then you just need to configure the right endpoint in your beat configuration. So like I've shown you. So you can use totally the same configuration. You probably, for the URL, you want to use your own URL, what you're pinging or collecting or whatever from. And then in the output, you just say, it's probably not that URL, but I don't know, maybe your Elasticsearch is running on localhost. And then you can just send it to localhost 9200 would be the default port. Ours is using a different port. And then if you have any authentication like a reverse proxy, you can provide that as well. But you just need Kibana and Elasticsearch somewhere. And yeah, you just throw your traffic there. So that should be very simple.
Yeah, but those those beats which actually are client to Kibana, right? They are binaries, right?
Yes, so you will need to run those on the server where you're collecting the information. Since they are written in Go, yes, you get native binaries, and you also we have Debian packages. So I can show you what I have done.
Yeah. I mean, my question is, for instance, what if I use Solaris?
Is Go supported on Solaris? I think so, yes.
No, probably.
Yeah, so as long as your operating system is supported by Go, you're good. Worst case is you need to compile yourself, but that is also very simple. The only operating system which we're not supporting is AIX, because there is no support for Go on AIX, and you're out of luck there.
Yeah, I see. Thanks. And the second question, if you don't mind, very quick one. Actually, when you are tracing the requests, will it work if there are like multi-threaded environment? Like, I'm just thinking how those ID lines are being traced. Most probably through the threads somehow.
So
and
generally, this is about HTTP calls. So the assumption is like you have like 5 different HTTP services, and you have calls between all of them. And how they are traced is you have a header information, and you need to keep that header information. And in the beginning, when the request is coming in, you need to generate that unique ID. And then you need your every request, as it's kind of working through the system, needs to keep that header information. And you need to have that like either in the log, so you can parse it out from the log, or you send it directly to Zipkin, but you will just need to keep that ID. As long as you keep that unique ID, you can correlate that. But basically, you will need to generate, if you're not using Spring Boot and Sleuth, it's basically what you're interested in. There is the Open Tracing Foundation. That is generally a vendor-neutral standard, and you have integrations into a lot of programming languages. So what you generally want to have is like whatever you have in your application, you want to integrate that library, whatever makes most sense for your app, and that is then generating these traces and keeps the traces, and then you can just send it out to Zipkin, and Zipkin can store it in Elasticsearch or wherever else you want to have it. Or you can just implement it yourself if it's not available for your system. But generally, the idea of the Open Tracing Foundation is that everybody has this problem that you want, or if you have a distributed system, you want to know what is going on and how it's all connected. So you're just generating that ID and keeping it through the HTTP headers throughout the whole system. And that's the main idea and what you need to have. And it's available for pretty much any programming language.
I see. Thanks a lot.
Sure.
Any other questions?
More questions. More stuff I should show you. Like just to, since we had the question like how do you install the beat? That is Ansible, but should be very simple to understand. So we have some URL from where we get it. That is the path to FileBeat, and then we have various binaries. So since I'm on Ubuntu, 64-bit, that is the package I want. Basically, you just add the right FileBeat configuration. You make sure it auto starts. And you do that for every beat. And that is what you will do on basically all your servers. So I do it for FileBeat, for MacroBeat, for PacketBeat. If you do it nicely in Ansible, you just have these placeholders. So I'm just reading out whatever information I have for that. And yeah, I know my Java applications will all log to that path. And whatever I have as JSON log files here, for example, I will just collect that and send it into Elasticsearch for FileBeat. Or for Heartbeat, yeah, I'm just pinging my one application. Metric beat, I use the system module. Here you can see I'm collecting that. That is basically what you get from top. So I'm interested in those. Every 10 seconds, for every single process I have, including C groups. So if you have any container information, we will capture that for you as well. I'm enriching it with the information from the cloud provider and then just writing it out to Elasticsearch or whatever. And PacketBeat is also pretty much the same thing. So capturing any network interface flows that was just like basically IP and TCP level. And we have support for higher level protocols as well. So I'm capturing DNS and HTTP here as well, enrich it with the cloud information, and then just send it out. So that should be very simple, and it's kind of like magic in the background. And since it's Go, it should also be pretty lightweight, since we had Logstash previously, but that was always a bit heavy and only for logs, but it started off as Ruby and is now JRuby, so you always need the JVM. So A, it needs time to start up, B, it needs Java eats memory for breakfast basically, and C, if you were not a Java programmer, people were not that keen to have the JVM on all their servers just for logging. So if you're using .NET, Go, Ruby, whatever, having the JVM like on your server just for logging, the ops people were not very pleased in general by that. Don't do that. Oh yeah, and since we have 2 minutes more or so, Terraform is also super simple. We had a Terraform talk yesterday. What I'm basically saying is generate my SSH key, do some DNS magic, and create my instances with that base image in that region with a specific size. So it's all automated. You basically run Terraform up, it creates the instances, you run Ansible through it to provision everything, and at the end today I will run Terraform destroy to get rid of all the instances, and it's not causing any more costs. And then I will reset my cloud instance, and then those passwords you have seen are also gone. So don't store any important information there. It will not be available for long. Any more questions? Yes.
Hi. So sometimes you want to trace like
something goes wrong and you want to trace a specific user, is that possible using the open trace? Or
I don't think it's easily. I don't think open tracing. I have not seen that easily done in open tracing. So what you would need to do is, I have accidentally. Wait, I have my Java application here. So what I would put that into the log and then start off in the log. So let me go to my Java application. And what I have basically done here, I have defined my log patterns. So I have my log lines, and what is more interesting, this is my JSON pattern. And if you can extract for logback the user, you would add a field here, user, or IP address, or whatever pieces of information you're interested in. You need to have those in your logging configuration. So if you can extract that information into your logging information, just I would add that structured in your logs, and then you can explicitly search for users or IP addresses or something like that. And then you can see what all the logs that user has been generated and touched. And I think that should be the easiest way to collect that. And since you will have in the log the trace ID as well, you can then go to Zipkin and see like what were his calls. So that would be the easiest workaround I see. But I would try to have like everything structured in the logs and start off in the logs and just pull like what were the logs that user caused and go from there. And in general, it is probably a good idea to have an eye on like the slowest requests, like spend 1 hour a week and just check like what were the 20 slowest requests I had over the past week, and then see, okay, it was these URLs were super slow, maybe I need to optimize that in the future. And because like your approach sounds very like reactive and not proactive, that somebody complains and then only then you start looking, I would always try to be a bit more like, okay, let's see what was slow in general to avoid having somebody complain at all. But if you have it structured in your log, throw it into the pattern, write it out to the JSON file, you have it. It's very easy to search through Kibana, so that should be. I hope that helps a bit.
yep, thank you,
Sure,
thank you,
sure,
thank you,
sure,
thank you,
sure.
thank you.